This video is about the solutions of partial try exam questions of chapter 2, the quadratic functions. So you can pause the video and try to solve the questions by yourself, and later on you can check the answer. So the first questions here is from the SPP, paper 1 and questions number 1. So given alpha and beta are the roots of the quadratic functions, 3x squared minus 5x minus 7 equal to 0. So A finds the value of alpha plus beta and alpha times beta. B, hence, form the quadratic equations with the roots of 2 alpha and 2 beta in the form ax squared plus bx plus c equal to 0. So the quadratic equations given here already written in general form. So by comparison, the A is equal to 3, the B is equal to negative 5, and C is equal to negative 7. So for questions A, alpha plus beta, as alpha and beta are the roots. So when alpha plus beta, so this refers to the sum of root. So sum of roots is equal to negative B over A. So we know that here the B is a negative 5 and A is a positive 3. So here negative become a positive, therefore alpha plus beta is equal to 5 over 3. Alpha beta, so this is alpha times beta. So this is the product of root. Product of roots is equal to C over A. The C here is negative 7 and A is 3. Therefore, alpha beta is equal to negative 7 over 3. That is for questions A. Now move to questions B. So we want to form quadratic equations with the roots of 2 alpha and 2 beta. So first, we want to find the sum of roots. So the sum of roots means 2 alpha plus 2 beta. So here we have the common factor of number 2. So I'm going to factorize this. So 2 bracket alpha plus beta. So from questions A, we know that alpha plus beta, the value is 5 over 3. So I'm going to substitute the alpha plus beta with 5 over 3. Solve this, you're going to have 10 over 3. Next, we're going to find the product of roots. So here means 2 alpha times 2 beta. You're going to get 4 alpha beta. And from questions A, we know that the value of alpha beta is equal to negative 7 over 3. So I'm going to substitute it here. Here you're going to have negative 28 over 3. So now we have the sum of roots and the product of roots. Now we can form the equations. So x squared minus the sum of roots x plus the product of roots equal to 0. So here we're going to substitute the sum of roots with 10 over 3, and don't forget the x, plus the product of roots is the negative 28 over 3 equal to 0. So noted here, the sum of root and product of roots are in the form of fractions with the denominator of number 3. To get rid of it, we're going to multiply each terms with number 3. So for the fractions here, the number 3 will be cancelled. Therefore, you're going to have 3x squared minus 10x minus 28 equal to 0. So that will be the quadratic equations form. Next question is from Pulau Pinang 2021, paper 1 and questions number 2. A, given negative 4 is one of the roots of the quadratic equations 3 bracket x plus h squared equal to 75, where h is a constant, finds the value of h. So the negative 4 is one of the roots. This means negative 4 is one of the value for the x, which means this negative 4 is also one of the points that satisfies these quadratic equations. So when you substitute the negative 4 into the x into the quadratic equations, the value on the left hand side will equal to the value on the right hand side. So for questions A, so I'm going to substitute the x with negative 4. So next, I'm going to move the 3 to the other sides. So it's going to be 75 divided by 3, which is going to give you the answer of 25. Next, I'm going to move the square to the other side. It's going to give you plus minus square root of 25. So the answer for the square root of 25 is equal to 5. So you're going to have one positive and one negative. Therefore, negative 4 plus h, the first one I'm going to write is equal to 5, and the other one will be negative 4 plus h equal to negative 5. So here the h is equal to 5 plus 4. Therefore, h is equal to 9. So the other one will be h equal to negative 5 plus 4, which is going to give you the answer of negative 1. So that will be the value of h for the questions A. Now, questions B. If alpha and beta are the roots for the quadratic equations, x squared minus 3x minus 5 equal to 0, form a quadratic equations with the roots 1 over alpha and 1 over beta. So from these quadratic equations, which already written in general forms, by comparison, the A is equal to 1, B is equal to negative 3, and C is equal to 5. So first, we're going to find the sum of roots and product of roots of these quadratic equations. So questions B. So first, the sum of roots. The sum of roots here means alpha plus beta, which is equal to negative b over a. So negative b is negative 3 and a is equal to 1. Therefore, alpha plus beta is equal to negative negative plus a positive 3. And the product of roots is going to be alpha times beta. This is equal to c over a. The c is a negative 5 and a is a number 1. Therefore, alpha beta is equal to negative 5. So now we want to form a quadratic equations with the roots of 1 over alpha and 1 over beta. So first, we want to find the new sum of roots using the 1 over alpha and 1 over beta. So it's going to be 1 over alpha plus 1 over beta. As this is a fraction, if you want to combine it as a single fractions, we need to equalize the denominator. So here I'm going to multiply it with beta and here with alpha. So here you're going to have beta plus alpha over alpha beta. So the value of alpha plus beta is equal to 3 and the value of alpha beta is equal to negative 5. So that is the one that we're going to substitute into here. So the numerator, which is the beta plus alpha, we're going to substitute it with 3 and alpha beta with negative 5. Therefore, the value is going to be a negative 3 over 5. And the new product of roots is going to be 1 over alpha times 1 over beta, which is going to give you the answer of 1 over alpha beta. Here we know that alpha beta is equal to negative 5. Therefore, it's going to give you the answer of negative 1 over 5. So now we can form a new quadratic equations with the roots of 1 over alpha and 1 over beta. So it's going to be x squared minus the sum of roots x plus the product of roots equal to 0. So just substitute the sum of roots. In this case will be the negative 3 over 5 x plus the product of root, which is negative 1 over 5, equal to 0. So here, negative negative will become a plus here. Here will become a minus. So here we have the fractions of 3 over 5 and 1 over 5. And to get rid of it, we're going to multiply each of the term with the value of the denominator, which is 5. So the number 5 here will be cancelled as well for this value of c here. Therefore, you're going to have the equations 5x squared plus 3x minus 1 equal to 0. So that will be the quadratic equations form. From SPM 2012, paper 2 and questions number 2. A quadratic equations x squared plus 4 bracket 3x plus k equal to 0, where k is a constant, has roots p and 2p, and p is not equal to 0. So A finds the value of p and of k. B hence form the quadratic equations which has the roots p minus 1 and p plus 6 in the form ax squared plus bx plus c equal to 0. Now look at the quadratic equations given here. This is not written in general form. So first I'm going to expand this. Therefore you're going to have x squared plus 12x plus 4k equal to 0. So now I can compare it with ax squared plus bx plus c equal to 0. Therefore the a here is equal to 1. The b is equal to 12 and c is equal to 4k. So now I want to find the value of p and k. So these equations have the roots of p and 2p. We know that the sum of roots is equal to negative b over a. So the sum of roots with the roots of p and 2p will be p plus 2p. So negative b, which is 12 over a, which is 1. So p plus 2p is 3p equal to negative 12. Therefore, p is equal to negative 12 divided by 3, which is equal to negative 4. Now we want to find the k. So we're going to use the product of roots. So product of roots is equal to c over a. So here is going to be p times 2p. So the c is 4k and the a is equal to 1. So here you're going to have 2p squared equal to 4 squared. So I can simplify the 2 and 4 or divide it with number 2. So I have p squared equal to 2k. So here I know the p is equal to negative 4. Therefore, I'm going to substitute the p with negative 4. Therefore, here you're going to have 16 equal to 2k. So move the 2 to the other side, is going to be 16 divided by 2. Therefore, k is equal to 8. So B, we want to form a quadratic equations which has the root of p negative minus 1 and p plus 6. So first, the roots p minus 1. I already know the p is equal to negative 4. So I'm going to substitute the p with negative 4. Therefore, I'm going to have negative 4 minus 1, which is equal to negative 5. The other root, which is p plus 6, is equal to negative 4 plus 6, which is equal to 2. So negative 5 and 2 is the root for the new quadratic equations. So first we're going to find the sum of roots. So in this case, it's going to be -5 plus 2, which is equal to -3. And the product of roots is going to be -5 times 2, which is equal to -10. Now, to form the quadratic equations, x squared minus the sum of root x plus the products of roots equal to 0. So now just substitute. Sum of roots is -3x plus the product of roots -10. So here we don't have the fractions, so we're just going to solve for the signs here. So x squared negative become a plus 3x, and plus minus a minus. So the equations will be x squared plus 3x minus 10 equal to 0. Next question is from Melaka 2021, paper 1, questions number 1. A is given one of the roots of the quadratic equations x squared plus bracket p plus 3x minus p squared equal to 0, where p is a constant, is negative of the other. So finds the value of the products of the roots. So the quadratic equations given here is written in general forms. By comparison, we know that the a is equal to 1, the b is equal to p plus 3, and the c is equal to negative p squared. So we want to find the product of roots, which is equal to c over a. Our c here is negative p squared and a is equal to 1. Therefore, the product of root is negative p squared. So we need to find the value of p and substitute here. So let's say the root of these quadratic equations, we label it using alpha, is stated here, is given one of the roots is the negative of the others, which means if alpha is one of the root, the other one will be negative alpha. Now, using the sum of roots, which is negative b over a, the sum of root here will be alpha plus negative alpha. So b here is going to be the p plus 3 over 1. So alpha plus negative alpha here is actually equal to 0. And here, if you expand it, you're going to have negative p minus 3. So next, to find the p, I'm going to move this negative p to the left-hand side. Therefore, p is equal to negative 3. Now I know the value of p. So now we can find the product of roots, which is the p here. We're going to substitute it with negative 3. So bracket negative 3 squared, we're going to have a positive 9. Therefore, here we're going to have negative 9 as the product of roots. Questions B. Find the range of value of x such that the quadratic functions f of x equal to 6 plus 5x minus x squared is negative. So this is about the quadratic inequalities, and the quadratic function is negative. The negative gives us the informations that this quadratic function is less than 0. So the function f of x here is less than 0. So f of x, we're going to replace it with 6 plus 5x minus x squared less than 0. So for the left hand side, we're going to rearrange this. So here the a is a negative 1. So I'm going to divide every term with negative 1 so that the a will become a positive. So we can factorize this easier. So for inequalities, when you divide with a negative number, the sign of the inequalities will be reversed. So here is going to be greater than 0. So factorize this, you're going to get x plus 1. The other bracket is x minus 6 greater than 0. So to find the range of value of x, we can use the graph sketching method, the number line method, or the table method. So here I'm going to use the graph sketching method. So from the factorization part here, we know that the a is positive. Therefore, the graph here is going to be a small graph. I'm going to draw a horizontal lines here for the x-axis. So when we let this quadratic inequalities equal to 0, we're going to find that the root, one of the roots is going to be -1, and the other root is going to be a +6. So -1 will be on the left hand side and 6 will be on the right hand side. So for the graph sketching method, the part that is above the x-axis is going to be the positive one, and the one that is below the x-axis is going to be the negative one. So now look at the factorization part here. It is greater than 0. When it is greater than 0, then we're going to look at the positive parts. So the range of value of x, so for the first one, here, it is moving toward the left, therefore the range will be x is less than -1. And for another one, which is going to the right hand side, the range is going to be x is greater than 6. So that will be the range of the value of x. Next question is from Negeri Sembilan, 2021, paper 1, questions number 3. Given a quadratic function f of x equal to x squared plus bracket p minus 1x plus 2p such that p is a constant, when f of x greater or equal to 0, a number line to solve this quadratic inequality is shown in the diagram on the right hand side here. Given alpha is a positive constant, find a, the value of the roots of the quadratic equations, b, the value of p. So from this quadratic equation, we know that the a is equal to 1, the b is equal to p minus 1, and the c is equal to 2p. So now look at these number lines here. The value at the dots here, if you look at here, this value is equal to alpha minus 5. And the value for the other one here will equal to alpha. So this is the number lines method. So here is the positive part, and at the middle here it is going to be the negative one. Or if you're using the graph sketching method, one of the roots here will be the alpha minus 5, and another one here will be the alpha. So here will be the positive part, and here will be the negative part. So this alpha minus 5, and then this alpha here is the root for these quadratic functions. So for question A, we want to find the roots, the value of the roots. So first, we're going to use the sum of roots, which is negative b over a. So the roots here, sum of root is going to be alpha minus 5 plus alpha equal to negative b, which is p minus 1, divided by 1. So it's going to be negative bracket p minus 1. Alpha plus alpha, you want to have 2 alpha minus 5 equal to negative p plus 1. Alright, so here I'm going to let the p to become the subject of the formula. So I'm going to move this negative p to the left hand side and 2 alpha minus 5 to the right hand side. So p is equal to 1 plus 5 minus 2 alpha. Therefore, p is equal to 6 minus 2 alpha. Alright, so the product of roots is equal to C over A. So the product of roots here is going to be alpha minus 5 times alpha equal to 2p divided by 1, which is 2p. So expand this, you're going to get alpha squared minus 5 alpha equal to 2p. So now, to find what is the value of the alpha, we're going to substitute the value of the p here with 6 minus 2 alpha. So expand for this part. 12 minus 4 alpha. So this one, I'm going to write it on top here. So I'm going to move everything to the left hand side. So alpha minus 5 alpha plus 4 alpha minus 12, it will be equal to 0. So negative 5 alpha plus 4 alpha is negative 1 alpha. So here, this is a quadratic function, so we can factorize this. So here you're going to have bracket alpha plus 3. Another one is alpha minus 4 equal to 0. Therefore, alpha is equal to negative 3, or the other one is alpha equal to 4. Now, the question stated that alpha is a positive constant. Therefore, we're going to reject the answer of alpha equal to negative 3. So now to find the value of the root. So the first root is alpha minus 5. Therefore, it's going to be 4 minus 5. So the first root is going to be negative 1. The other root is just alpha. So straight away, the other root will be 4. So now, for questions B, we want to find the value of P. So we know that the P is equal to 6 minus 2 alpha. Now we already confirmed that the alpha is equal to 4. So I'm going to substitute the alpha here with number 4. 6 minus 8, therefore P is equal to negative 2. Kelantan 2021 paper 1 questions 11. A. Determine the range of x for x bracket 8 minus x less than or equal to 15. So A is about the quadratic inequalities. So first I'm going to expand this and move the 15 to the left hand side. Therefore you're going to have 8x minus x squared minus 15 is less than or equal to 0. Next I'm going to rearrange this in the form of ax squared plus bx plus c. So here the a is a negative 1. So I'm going to divide every terms with negative 1 so that I have the a with the positive numbers so that I can factorize this easily. Therefore, you're going to have x squared minus 8x plus 15, and the signs here will be reversed as you divide it with negative 1. Now I can factorize this. So the first bracket is x minus 5 and the second bracket is x minus 3 greater than or equal to 0. So from this part here, when we let the x minus 5 and the x minus 3 here equal to 0, you are able to find the roots. So the x is equal to 5, another one is x equal to 3. So we're going to solve this using the graph sketching method. So from the factorization part here, we know that the a is a positive value. So we're going to draw a small graph here. And this is going to be the x. And we have the roots of 3 and 5. So 3 is going to be on the left hand side and 5 on the right hand side. So above the x-axis is going to be the positive 1 and below the x-axis is the negative ones. Now, look at the factorization part. It's stated here, this is greater than or equal to 0. Therefore, we're going to look at the positive part. Therefore, the range of x for this quadratic inequality, the first one is for this part, the x is less than or equal to 3. And for this part, the x is greater than or equal to 5. That will be the range of x for these quadratic inequalities. Now, let us move to questions B. The roots of the quadratic equations 2x squared minus 7x plus 1 equal to 0 are alpha and beta, while the roots of the quadratic equations 8x squared plus px plus q equal to 0 are alpha plus beta and alpha squared plus beta squared. So calculate the value of p and q. So for questions B, so first we're going to look at the quadratic equations of 2x squared minus 7x plus 1 equal to 0. The roots for these quadratic equations is alpha and beta. Therefore, the sum of roots, which is the alpha plus beta in this case, is equal to the negative b over a. So the b here in this case is a negative 7, while the a is 2. Therefore, the alpha plus beta is positive 7 over 2. And the product of root, which is the alpha times beta, this is equal to c over a. So the c here is 1 and the a is 2. Therefore, alpha beta is equal to 1 over 2. So now we already have the value of alpha plus beta and alpha beta. So next, when we look at these quadratic equations here, the roots are alpha plus beta and alpha squared plus beta squared. So I'm going to use the red color here. So for the roots, alpha plus beta for the quadratic equation 8x squared plus px plus q, straight away we know that this is equal to 7 over 2. And alpha squared plus beta squared, this is the same as bracket alpha plus beta square minus 2 alpha beta. So alpha plus beta we know that is equal to 7 over 2. And alpha beta is equal to 1 over 2. Solve this, you're going to get the answer of 45 over 4. That will be the value of alpha squared plus beta squared. So now, the sum of roots of the quadratic equation at x squared plus px plus q, we're just going to use these two numbers. So the sum of roots is going to be 7 over 2 plus 45 over 4. This will equal to the negative b over a. So here the negative b, the b is the p, and the a is 8. So 7 over 2 plus 45 over 4, this will give you the answer of 59 over 4. So p is equal to 59 over 4 multiply the negative 8. Therefore, p is equal to negative 118. So next, we're going to use the products of roots. So the product of roots will be 7 over 2 multiply 45 over 4. This will equal to the c over a. So in this case, the c is the q, whereas the a is the number 8. So 7 over 2 times the 45 over 4 here, we will have the answer of 315 over 8. Therefore, Q is equal to 315. Sabah 2021, paper 1, questions number 2. A. Given a quadratic equations 3x squared minus 6px plus p equal to 0, where p is a constant, has only one solution. Finds the value of p. So from the quadratic equations given here, which already written in general forms, the A is equal to 3, the B is equal to negative 6p, and C is equal to p. This quadratic equations has only one solution, which means this quadratic graph touches the x-axis at one point only. Therefore, the discriminants for these quadratic equations, which is the b squared minus 4ac, is equal to 0. So now we're just going to substitute the bac into here. So the b is going to be bracket negative 6p squared minus 4, the a is 3, and the c is p. So negative 6p, when we square it, we're going to have 36p squared minus, here we're going to have 12p equal to 0. So next, I'm going to divide each term here with number 12. So when 36 divided by 12, I'm going to have 3p squared minus 12 divided by 12 is just 1. Alright, so I have a common factor of p. Therefore, I can factorize it. So I'm going to take the p and put it outside bracket. So here I'm going to have 3p minus 1 equal to 0. So the first solution is that the p is equal to 0. The other one will be 3p minus 1 equal to 0. Therefore, p is equal to 1 over 3. So that will be the value of p for questions A. Now, questions B. Quadratic equations x squared plus x equal to 3kx minus k squared has two different real roots. Find the range of value of k. So for questions B, it has two different real roots, which means the graph of these quadratic equations intersect the x-axis at two different points. Therefore, the discriminant, the b squared minus 4ac, is greater than 0. So first, for these quadratic equations, we're going to write it in general form. Therefore, I'm going to move everything to the left-hand side. And for this part here, I can factorize the x. So I'm going to put a bracket 1 minus 3k x plus k squared. So this is the general form of these quadratic equations. So from here, the a is equal to 1, the b is equal to 1 minus 3k, and the c is equal to k squared. So the discriminants for the questions B, the b squared minus 4ac is greater than 0. So the b bracket negative 1 minus 3k squared minus 4. The a is 1 and the c will be k squared. So expand this, you're going to get 1 minus negative 3k, double it, you're going to have 6k plus negative 3k squared it, you're going to have positive 9k squared minus 4k squared greater than 0. So for the like term, 9k squared minus 4k squared, here you're going to have 5k squared minus 6k plus 1 greater than 0. So from here, I'm going to factorize it. So the first bracket is 5k minus 1, and the second bracket is k minus 1. So when I let the bracket here equal to 0, then I will able to find the roots for these quadratic inequalities. So the k is equal to 1 over 5. The other k will be equal to 1. So we're going to solve this using the graph sketching method. The a for these quadratic inequalities is positive, therefore we're going to have a small graph here, and this one will be the x-axis. So the root one of it is 1 over 5, so it's going to be on the left hand side, and the one with the 1 will be on the right hand side. So the regions above the x-axis is going to be the positive one, and below the x-axis is going to be the negative one. So now let us look at the quadratic inequalities when we factorize it. From here, it's stated greater than 0. So which means we're going to look at the solutions will be at the positive sides here. So the range of the value of k, so the first one for this side, as it's moved to the left hand side, therefore the k is less than 1 over 5. The other range will be on the right hand side, this one. When we move to the right, k is greater than 1. So this will be the range of the value of k. Terengganu 2021, paper 2, questions number 2. So diagram below show parts of a quadratic graph f of x equal to ax squared minus x plus c. So where a and c are constant. So questions A, state the range of value of x if f of x is less than or equal to 0. So when the functions f of x is less than or equal to 0, which means we're going to look at the negative part. So from this graph, the P and Q, they are the roots of this quadratic graph. So the parts above the x-axis is going to be the positive ones, and below the x-axis is going to be the negative one. So as the f of x is less than or equal to 0, so we're going to look at the negative one here. Therefore, the range of the value of x will be in between the P and Q. So the answer for A is x is greater than or equal to P and less than or equal to Q. That will be the range of the value of x. Questions B. Express the range of the value of A in terms of C. So from the graph given here, this quadratic graph have two different real roots, as the root is P and Q. Therefore, for questions B, the discriminants for these quadratic functions will be greater than 0. So from these quadratic functions here, we know that the A is equal to A, the B is equal to negative 8, and C is equal to the C. So B here is negative 8 square minus 4. The A will remain as A and C will remain as C. So here I'm going to have 64 minus 4AC greater than 0. So I want to express the range of the value of A in terms of C. So I'm going to move this 64 to the other side. It's going to be negative 64. Then I'm going to move the negative 4 to the other side. So it's going to be negative 64 divided by negative 4. Don't forget, when you divide with a negative number, the inequality signs will be reversed. So it's going to be less than negative 64 divided by negative 4. So here I'm going to have a positive 16. So A is less than 16 divided by C. That will be the range of the value of A when we express it in terms of C. Now we're going to move to question C. We want to prove that P plus Q over PQ is equal to 8 over C. So from the graph here, the P and Q, they are the roots of these quadratic functions. So P plus Q, this is the sum of roots. Therefore, it is equal to negative B over A. So from these quadratic functions, the B is going to be negative 8 and the A is still going to be A. So here we're going to have positive 8 over A for the P plus Q. And for P times Q, this is going to be the products of roots, which is equal to C over A. So in this case, it's still going to remain as C over A. So when P plus Q divided by PQ, this is the same as 8 over A divided by C over A. So here we can write it in the form of multiplication. So we're going to inverse the C over A. This will become A over C. Then we can cancel for the A. Therefore, P plus Q over PQ is equal to 8 over C. Therefore, we already proved that P plus Q over PQ is equal to 8 over C.